So we've been working with elimination, which is a method that we use to solve a system of linear equations. The idea is that we line these equations up in standard form so the like terms are above each other. And we hope that we have opposites so that we can add straight down and eliminate one of the variables. Now if you take a look at this system, you're going to notice that we do not have opposites. Here I have a 5x and a 3x. And here I have a 2y and a 7y. Neither of those pairs have opposites. In fact, the values aren't even the same. So what we're going to need to do is we're going to need to use multiplication in order to force a pair of opposites. And the strategy that we use on this is we look for a common multiple. We can either look for a common multiple of 5 and 3 or of 2 and 7. It just depends on what you want to multiply by. In this example, I'm going to try and get opposites in that green circle, so I'm focusing on the 5 and the 3. What I'm going to do is I'm going to shoot for a positive 15 up here where the 5 is, and I'm going to shoot for a negative 15 where the 3 is. So what that means is, on top, I'm going to multiply every single term by 3. Remember, we have to distribute this thing, right? And we have to multiply it on both sides because we have the multiplication property of equality. That'll give me a 15 in the upper left position there, where the x term is. To get a negative 15 on bottom, I'm going to have to multiply everything on the bottom by negative 5. So I'll distribute that negative 5 all the way around. And we'll see what that does for us. So on top, by multiplying by 3, I end up with 15x plus 6y equals not negative 1. I almost made a huge mistake there. Please don't put negative 1. You got to multiply by 3. So that's going to be negative 3. For the bottom equation, I'm multiplying everything by negative 5. So I will have negative 15, which is great news, negative 15x, minus 35y equals negative 55. Okay, that's the new system that we're going to solve. We're going to solve this system. Even though it looks like the numbers are a little bigger than we're used to seeing, everything's going to work out great. We're going to solve this system. We're going to be in good shape. So on the next slide, we'll take this system and we'll try and solve it. So here's the new and improved system that we created by multiplying our equations by 3 and negative 5. Now we're ready to do our elimination. The elimination step simply means you're going to add straight down. Excuse me. So when we do elimination, we add straight down. The 15x's are going to cross out. That's what we were shooting for. We have to do 6 plus negative 35. Don't panic. It's just negative 29y. And we have to do negative 3 plus negative 55, which is negative 58. Again, don't panic. We're going to divide by negative 29 on both sides. And the 29s are going to cross off. Here we get y equals 2. So that's good news. We're halfway home. The y coordinate of our solution is negative 58 divided by negative 29, which is positive 2. Great news. Now here's where it gets a little crazy. We actually have 4 equations to choose from. 4 equations that we can plug this y into. We can either choose one of the original equations or we can choose one of the new ones that we made. Now, I'm going to go back to one of the original equations that we had, which was on the bottom of the system. And, oops, I made a little blue mark there for no particular reason. And I'm going to plug the 2 into that bottom equation because everything was positive there. It was, I'll remind you, it was 3 times x plus 7 times y. And where the y is, that's where I'm going to plug in this 2. Equals 11. That was the equation. And remember, this is just 14 right here. So basically, we're going to solve 3x plus 14 equals 11, equals positive 11. We'll do that on the final slide. So we substituted the 2 in, and 7 times 2 is 14, and we're ready to solve for x now. We need 2 inverse operations. We need minus 14 on both sides. When we do that, we get 3x equals negative 3. Divided by 3 on both sides, and we are home. x equals -1. So the solution to our system is our x value, which is -1, and our y value, which was 2, -1, 2. That's the solution to the system. Remember, in this particular case, we had to use multiplication on both the top equation and the bottom equation because we wanted to get those opposites, 15 and -15, so that we could use elimination. This is not an easy technique. It takes a little time to get used to, but once you get the hang of it, I think you'll find that in cases where the systems are in standard form, it's pretty efficient for getting the solution. Good luck.